enzyme hexokinase. The non-physiological reaction, one that doesn't happen in the cell, or you just hope that a phosphate and a glucose come together to make a product, it's uphill. So because the delta G is positive, you've got that logarithmic fact going on there. That means the equilibrium constant is going to be less than 1, in this case very less than 1. This is saying that out of every 1,000 molecules you look at equilibrium, only 5 would be glucose 6-phosphate, the other 995 would be the starting material. Very unfavorable towards making product. Once you link it to ATP hydrolysis, though, the equilibrium constant becomes huge. 1,000 times, 1,400 times more product than reactant. So this is where the uncoupled reaction starts with. This is the biological job you want to do. It's uphill, unfavorable equilibrium constant, way less than 1, and it's turned into a gigantic positive, favorable reaction by linking to ATP hydrolysis. So just looking at those numbers, you can say that the effect of coupling it to ATP was to increase the equilibrium constant by 40,000,000-fold. So a huge increase in favorability. These are under standard conditions in the cell. This ATP linkage might be worth 1,000,000 or 100,000,000 times the increase in favorability. So you can look these things up, the relationship between equilibrium constant and delta G. We're almost up here, almost as high with ATP. Its delta G is low 30s, depending on the circumstances you're talking about. So a negative delta G in that range almost shifts the equilibrium constant by 1,000,000.